Welcome back to The Explainer. Today, we are diving into something that literally bridges the cold, hard world of formal mathematics and our deepest, most profound human emotions. We're going to walk through an absolutely fascinating formal derivation by Ryan McLean, one that uses topological physics to examine the very nature of identity, memory, and loss. It's a heavy topic, but the math behind it is incredibly beautiful.
So, we're starting with a surprisingly simple yet incredibly weighty question. If another person genuinely became part of your history, can death permanently separate you while you remain the exact same person? It's something we've all probably wondered about in some form. And as we're going to see today, formal logic answers this with a definitive, structural no.
So here's how we're going to tackle this today. First, we'll look at the problem of severance. Then we'll talk about how you are essentially a recursive save file, dive into the actual math of identity, prove why death is not deletion, and finally bring it all together at the shared table. Okay, let's start right at the top with the problem of severance. What actually happens when we try to permanently delete a piece of our past? And to be clear, we're not just talking about forgetting where you put your keys. We're asking if something that has actively entered the generative history of who you are can simply be removed while you magically remain the exact same person. The framework we're using here is a total game changer. It shows us that we can't just think of our identity as a static list of memories, or like a journal where you can just rip out a bad page. It doesn't work like that. Identity is a structure dynamically built over time. Every interaction that genuinely modifies your future accessibility becomes an active, structural part of the engine generating your tomorrow. To really ground this, think about what the great Henri Poincaré said. He noted that mathematicians do not study objects, but rather the relations between objects. Reality is fundamentally defined by relationships. And, that core principle serves as the absolute foundation for this entire mathematical proof we're exploring. Before we get into the heavy math, we need to set up our rulebook so we know how this game is played. Let's define some of the specific vocabulary used in this framework. First up are players. Player 1 is simply the local origin from which you experience the world, because you never experience the world from nowhere. Player 2 is just another person seen from your perspective. And crucially, they aren't just some lesser NPC or side character. From their own frame, they are player 1 too. It's really just about defining the local point of rendering. Next, we have your history state. And what's super interesting here is that your history state isn't a dusty chronological diary. It's an active, accumulated constraint structure. Meaning, if an encounter changes what you can understand, or fear, or love, or expect next, it is structurally inside your history state right now. Then there's the generator. This is the mathematical operation, the map, that takes your current history state and continuously builds the very next one. It doesn't pull your future out of thin air. Its input is precisely the accumulated relational structure that exists right at this exact moment. To put this in super plain English, the author includes this great little section called Angela's Explainer, which he originally wrote for his daughter. Imagine your life is a giant save file in a video game. The game uses everything you've encountered to build the very next level. If you made friends with a dragon in level 1, the game's save file literally updates, and level 2 is built using that exact updated file. The game keeps the receipts. So the crucial takeaway here is that time is exactly this sequence. Time is the ordered trajectory produced by the generator repeatedly doing its thing. It maps history state 0 to history state 1, and so on. Time doesn't bypass your history. It actively, continuously reapplies it. Or, if you prefer breakfast food over video games, think of a magic waffle maker. The generator is the waffle maker, and your history state is the batter. If you alter that batter by tossing in some chocolate chips, or, in our framework, adding a real relationship that changes your future, that waffle maker is inherently going to produce a different waffle. You absolutely cannot alter the batter and then claim the waffle is exactly the same, right? All right, rulebook established. Now, let's step into the actual math. We're going to borrow a concept from complex physics to prove a major point about human connection and how identity is preserved. The paper grounds all this math in the work of topology pioneers, specifically folks like Heinz Hopf and the modern work of Jennifer Nielsen. They focus on the global structure of spaces. More specifically, Nielsen works with unified, deeply connected structures using the complex Hopf fibration. Basically, they're looking at objects that aren't just a pile of loose detachable strings, but deeply interwoven wholes.
Which brings us to Nielsen's non-factorability principle. It sounds like a mouthful, but the idea is actually quite elegant. It states that in a unified structure, you simply cannot remove a core constitutive component without changing the object completely. If a piece genuinely helps make the thing what it is, you can't just factor it out and pretend the original object is magically preserved.
Going back to Angela's explainer analogies, imagine you're building a treehouse. Now, if you paint the walls blue, sure, it's the same treehouse. But if you pull out the main load-bearing beam holding up the roof, yeah, you don't have the same treehouse anymore. You just have a very expensive pile of wood. That beam was constitutive.
So how does this tautology map to, well, life and death? That brings us to the main theorem, and this is where things get really profound regarding permanent severance. The formal proof bridges these concepts to show that two specific outcomes are completely mathematically incompatible. Because your history state is a unified constraint structure, if another person genuinely changed your future, they became a constituent relation. Therefore, trying to permanently erase them fundamentally breaks and changes the object that generates your identity. And that leads to a massive realization. Death can interrupt your local rendering, meaning player 1 literally can't see player 2 on their screen right now. But death absolutely cannot act as a magical delete button for your history state. Time does not erase history. Time repeatedly reapplies the save file that still contains that person. Okay, let's bring this down to earth. What does this mathematical reality actually feel like for us? Because at the end of the day, we aren't just equations, right? We are people. What happens to these unresolved relations that time just keeps carrying forward? Well, as Hopf pointed out, business depends on action. You can't move forward by hesitating. Mathematically, for a recursive system to reach a stable, fixed point where it isn't just constantly generating friction and unresolved loops, those relations must reach what the paper calls constraint closure. The future is mathematically obligated to negotiate with the past until it finds that closure. In human terms, resolving these lingering constraints doesn't mean moving on by deleting someone from your mind. It looks like reconciliation. It looks like communion. As the author points out, it looks like distinct individuals sharing a table. You don't just melt together into a friendship smoothie. You remain distinct, but the brokenness is resolved into a shared presence. It's beautifully summed up like this. Whatever becomes a real part of your history will continue to be reiterated by time, shaping your future until it finds its resolved place. You quite literally cannot preserve who you are by permanently excluding the people who helped make you, well, you. Which leaves us with one final profound thought to chew on. If death only interrupts the screen but literally cannot permanently sever what time continues to generate, who is still actively shaping your story right now? Turns out, reality has a memory. And love, mathematically speaking, is a structural component of the universe. Thanks for joining me for this explainer. I hope it gave you as much to think about as it gave me.